Yes. Hello everyone, we are Group 10 and today we would like to present our project Customer and Contract Management System. Let's explore how we build this system together and see how useful it is. Here's what we will cover today. We will give you some basic information of this project. Then we move to the main part. First is how we design our database. Then we talk about how we actually build it and manage the database. Furthermore, we illustrate how we integrated Python into this system to manage database and enhance user experience through graphical user interface. Last but not least, there are some recap of our system. Now move on to the first part, introduction. I will briefly define the concept here for you. Talk about the background. So handling customer contract and payment efficiently in today's business require more than just spreadsheet and Excel. Our project was building a system to manage it on MySQL database server and connecting it with Python, making it easier for users to interact with the system and also supporting revenue reporting and analytics. So the system covers 5 main features: customer profile, contract status tracking, service and pricing detail, invoice generation and record payment, and revenue reporting. It also includes data objects like trigger and store procedures, security features, and some application of Python. About the tool and technology used, Draw.io and ERE Plus we use for design the database structure. The backend is built on MySQL to manage the database. We integrated libraries like MySQL, Connector Python for database access, and Tinter for the UI. Figma was used to prototype the UI layout. Our system is designed for four-main group: the sales team to manage contract, the finance department for billing and payment, administrative staff for customer record, IT staff for maintaining performance and security. In this, move on to the main part. In this session, we present the core structure of our system, entity relationship diagram. This is the entity relationship diagram of our database, showing how our 6 main entities are related. Here are the key entity: customer, contract, service table, and the service agreement table. Link service and contract in many-to-many structure. Invoice and payment table. Each customer can have many contracts. Each contract can contain multiple service. Each invoice can receive multiple payments. We also summarize the schema created from our database, showing the relationship, primary key, and foreign key of each table and their constraint. This compact view helps us ensure proper data normalization and referential intuitivity between all entities. We design 6 tables in total: customer table, store client profile and contract info, and connect one-to-many with contract table. User can have multiple contract table here, track the status of contract per customer, and connect many-to-many with service table. One contract can have many services, and one service can align multiple contracts. And about the service table, we define our catalog of offering. The service agreement table. This junction table resolves the many-to-many relationship between contract and service. Each record includes service priority and date. The invoice table stores billing information per contract, and each invoice can have multiple payments. Finally, the payment table that's responsible for record payment, including payment method, date, amount. Multiple payment can be in one invoice. For example, invoice for contract A contain multiple payment for different service. Here is the overall of the explanation of our tables. Now we move on to the how we build a database.
With the given 6 table, we first created the database called contract management. with the statement create database and use database. Then we insert data, the sample data with the statement insert into. For example, we have a customer, Saul Olison, who has an 18-month contract using Analytics dashboard service and has paid $150. We also created advanced data objects. The first one are indexes. We have two indexes in this case. The first one is to look up contracts by customer ID and finding invoices by status. These two indexes speed up queries, especially in large database with thousands of records. We also created views. Views are like dashboards for your business. We created 4View. Active contracts will give you about show you about the contracts that are still active. Unpaid invoices show pending bills, and overdue invoices flags late payments. And the last one, the customer billing summary view, totals what's billed, paid, and owed per client, giving you a clear financial snapshot. These views deliver instant insights without sifting through raw data, helping you track finances and contract statuses at a glance, so you always know where your business stands. We also created store procedures. Store procedures automate repetitive tasks. The generate invoices procedure calculates invoice totals from contract service and quantities, creating bills instantly. The record payment procedure logs payment and block overpayment to prevent errors and marks invoices paid when settled. These act like a robotic assistant handling bill accurately and saving hours of manual work, ensuring your financial processes run smoothly without mistakes. For example, when an user trying to use the record payment procedure to enter a wrongful payment and overpayment, it will return payment exceeds the invoice amount and overpayment is not allowed. We also created user-defined functions. These are like business hotline, answering key questions fast. The get remaining contract value calculates unpaid contract amounts. Get customer total, spend totals client payment. Get monthly revenue, tracks earning for a specific month. And get customer last payment date, finds the latest payment date. These functions provide quick, actionable data for financial planning and client management. No complex queries needed. We created triggers and schedule events like guardrails and automation. Triggers and the schedule event keep things tight. The update contract stated after payment trigger marks contracts completed when all invoices are paid. The prevent manual contract completion trigger blocks marking contracts completed if unpaid invoices remain. And the update overdue invoices event runs daily, flagging unpaid invoices past due date as overdue. These are like silent guards, ensuring accuracy and data integrity without manual effort. And finally, we created role-based access and encrypt the sensitive data. Our security is rock solid. We created users with unique passwords and assigned roles. Apart from the user with the full admin privileges, we created sales to manage customers and contracts, finance to handle invoices and payments, and reporting gets read-only access for analytics. Sensitive data like phone numbers, addresses, payment amount, and methods is encrypted with AES, making it unreadable without the key. This setup is like custom keycards and a digital vault, ensuring only authorized access and data protection. Now our teammates will talk about how we connect to this MySQL via Python and data manipulation via Python.
First,
Also, this, as you can see, the amount and payment in the payment table is encrypted, so it's not showing anything but blocked. Okay, your turn.
First, I would like to cover the essential for remote MySQL access. First, the client and the server must be on the same network, LAN, or internet. The MySQL server must be running on the host to accept the connections. Ports 33006 must be open through firewalls or connections will fail. Finally, the remote user needs proper permissions to access the database. Visual network with client, server, open ports, and permissions. Next slide. Next slide. We connect to a remote MySQL database in just three steps. Step 1, grant access with SQL command, grant all privilege on database to user identified by passwords. Step 2 is to install the Python MySQL connector, pip install MySQL connector Python. Last step, write Python code using MySQL.connector.connect with host user password and database. Next slide. Once connected, you can manage the database from Python, insert data secure with parameterized queries like adding a customer names and email. Update records with conditions such as changing an email by ID, delete records using where clause for safety. You can also create or drop table programmatically. Slide. Now let's explore creating and dropping tables. To create a table, use a create table statement in Python, defining fields like an auto incrementing ID and timestamp. This is a great for automation and testing. To drop a table, use drop table if it exists to avoid errors if table doesn't exist. Next slide. Let's look at MySQL views. Virtual table defined by SQL queries. Views simplify complex query and restrict data access. A Python function query view connect to the database, run select from view name and fetch data. For example, a customer billing summary view show invoice, payments, and balance. Next slide. Finally, we'll cover the custom Python functions for MySQL. This function runs basic SQL queries for analytics and automations. For example, get remaining contract value. Except calculates the unpaid contract. The statement get customer total spend. It have to calculate the total spend of a customer. And lastly, the guest customer last payment dates is have to get a customer latest payment date. And the rest of our presentations will be presented by my teammates.
Hey guys, my name is Hung and I will continue the presentations. So let's start with a quick overview. We have created 4 charts to provide a snapshot of key business metrics. They help us to visualize how the company is performing in terms of revenue, customer growth, and service usage. Also, customer spending also. Together, they offer a data-driven operation to identify trends, risks, and areas which we can improve. Now, looking at the monthly revenue trends, as you can see, in January 2024 was our peak with over 300 units in revenue. However, the revenue declined sharply afterward and dropped back to 100 by April. This shows that while we had strong start, we need to focus on maintaining stable revenue throughout the year. So moving on to customer operation, each month we consistently gaining 1 new customer. which is steady but not growing. Also, there are some dead label issue in the chart that we should fix, but overall, this tells us we need strong outreach strategy to expand our customer base. Moving on to the service distribution, here we see how customers are using our service. Database backup is most used with over 44% of total usage, followed by IT support and email hosting. On the other hand, some services like cloud hosting and analytics dashboard are barely used. This may mean we need to reposition and improve them. Finally, top 10 customer by spending. Finally, this chart shows that a few customers like Nghiêm Trọng Mạnh account for most our revenue. Others like Tourism and Nguyễn Quốc Hùng also contribute significantly. But notice the sharp drop among the last few. This suggests that we are heavily dependent on few clients, which could be risky. Besides financial logic, we also develop a graphical user interface using Python. This GUI is designed to be intuitive and secure with login system and a centralized dashboard. Through the interface, user can manage customer and contracts, build services, and handle invoice and payments all in one place. This greatly improves the user experience and system efficiency. So let's start with the login page. This screen validates the user credential to ensure secure access to the system. Once logged in, the user is directed to the dashboard, which acts as the central hub. From here, users can easily access all modules, contracts, customer services, invoice, and more. Another core module is customer management. Users can add new customer, edit their details, delete entries where necessary. And as shown here, the interface supports input fields like name, email, gender, and status. This makes customer data easy to update and always accessible. Now let's move to the contract and service handling. User can create new contracts by linking them to specific customer. Meanwhile, the service catalog display available service along their pricing. This module gives business full control over their service offering and agreement. And finally, our system includes a module for invoice and payment. The invoice page lists all contracts with their status, paid, unpaid, or overdue. The payment record logs every transaction with details like amount, the date, and method. These records are critical for financial accountability and reporting accuracy. So, in summary, we successfully create a database and apply advanced data objects to manage structured data. Using Python, we establish a connection to the database and perform key operations like querying and updating records. Finally, we build a more graphical user interface to simulate user interaction, demonstrating how these components work together in real-world applications. So that is our presentation. Thank you for listening.
Hello, it's me again. This is a prototype of our system. I've created it on Figma. It allows users to stimulate the experience of using the real application without writing any code. First, we begin with the login interface. This is where users log into the system using their assigned account credential. In this example, it is me, Yingzu. So after a successful login, the user is taken to the dashboard. This dashboard provides a quick overview of the system key data, including the active contract, total customer, total number of customer, unpaid invoice, and overdue payment, and some recent activities. It helps you to get a summary of the system status at a glance. Now, next we will move to the customer section. Here we can see the list of all registered customer. All of them are mock data with information format like our database, name, email, phone, status. We can edit it easily by clicking the button and delete it. So to add a new customer, the user simply click on the Add Customer button. This opens a form where they can input details like name, phone, and email. So it is a simple and user-friendly process designed for non-technical users. Now let's look at the contract sections. This page shows a list of all current contract and each contract link to a customer and contain key information. Here I contain key information like start and end date, contract value, and status. Now let's try to stimulate to add new contract here. The user may fill this form, such as I will I will choose the customer I just created here. Around 5 months. When I create a new contract, it immediately store this contract in the system. Like here, you can see it. The contract name, the customer, and the date, as well as the value and status. Now move on to the service sections. Here we display the service currently offered by the company, and as you can see, I can interact with the add new service because of my access level. Move on to the invoice page. This we show a list of all invoice, including the status and total amount. User can easily check it which invoice is unpaid, paid, or overdue. So to generate new invoice, user click generate invoice here. I will choose the contract I just created here. Now and do it. I 1 day, for example. The status when I create the new invoice here is unpaid, 2000 plus tax. So immediately store in the system. In payment section, user can view or record payment of customer. They can also record a new payment of existing invoice by clicking the Add Payment button. Record payment here. I will select the invoice that haven't paid here, and I just created it. It's today, and I will pay it. And it immediately stored in the system. Not only that, it's also immediately change the status of the invoice. Change the status of the invoice simultaneously here, from the unpaid to the paid. Thank you for listening our prototype. This UI was created to make the system user-friendly, especially for non-technical users in departments like Shell or finance. It simplifies tasks like customer and contract management, invoice generations, and payment tracking without needing to write any code.